Hi everyone, welcome to this video on topic C10, which is called using resources. So there's two types of energy resources, renewable and non-renewable. So renewable basically means that we can reuse them, for instance timber, trees, we can replant trees in order to get that energy source again, and we're not using them all up quicker than replanting them. Also solar energy or wind energy, we're not going to run out of the sun or wind, so they're all renewable. Non-renewable is the opposite to that. They're not forming as quickly as we are using them up, so once they're gone, they're gone. And that, for example, is nuclear fuels and fossil fuels. So scientists are trying to create more renewable energy sources and encourage us to use more renewable energy sources because we will one day run out of fossil fuels. So sustainability, another definition for you. So sustainability basically means that we take account of the needs of the current generation whilst not damaging the lives of future generations. So you may have heard people talking about sustainable living, and it's all about taking care of our planet, taking care of the energy resources, not wasting, recycling, etc., so that our children and our children's children and, in thousands of years, billions of years, life can still go on. So there is something called the LCA, or the Life Cycle Assessment. Now the Life Cycle Assessment, or LCA, basically looks at every stage of a product's life and it assesses the impact it would have on the environment. So there's four main stages to creating a product, and the first one is getting the raw materials. So what is that table made out of? Is it made out of metal? Is it made out of wood? Is it made out of marble? And can we get that material in a non-damaging way? Two is manufacture and packaging. Manufacture and packaging. So again, can that packaging, can the cardboard box it came in be recycled? Number three is using the product. So is there any harm to the environment whilst I'm actually using this product? And then four is product disposal. So can it be recycled? Is it biodegradable? Or do I have to throw it into landfill, etc.? So let's focus on the two that you need to know about, and that's plastic bags and paper bags. So the LCA for a plastic bag and a paper bag, using those four stages. So I'm just going to split the board. Let's do plastic bags over here and paper bags over here. You could get a 6-mark question asking you to compare the advantages and disadvantages, or pros and cons, of plastic bags and paper bags. So let's start with stage one, which was raw materials. So the raw material for a plastic bag is crude oil. Now crude oil is a mixture of hydrocarbons which companies get from drilling down to the seabed. That crude oil is basically the remains of dead sea creatures. Paper bag, its raw material is timber, so wood. Okay, that's number one. Manufacturing and packaging, so I'll just put manufacturing and packaging. So crude oil has to be put through fractional distillation. Now, fractional distillation, if you remember from one of the chemistry topics earlier, fractional distillation uses a lot of heat energy in order to create that really, really high temperature at the bottom of the column, because fractional distillation is all about separating out those components of the mixture by boiling point. We then have to crack the alkane hydrocarbon chains that we make, so cracking, so fractional distillation, cracking, and then polymerization. So those are the steps. Polymerization, and that basically gives us the more useful chains in order to make a plastic bag. One benefit though to fractional distillation is all those different fractions can be used. So one fraction might be petrol, one fraction might be diesel, one fraction might be to help make these plastic bags. So actually there's less waste products because there's a use for all the other components in fractional distillation. Timber, on the other hand, has to be pulped, which is a process that uses lots and lots of energy and therefore is costly, and lots of waste made. So that's quite a expensive and wasteful process. So I've just run out of space, so I'm going to wipe these two and carry on with 3 and 4. So process 3 is actually using the product. So using the product, using a plastic bag, you can reuse plastic bags because they're fairly strong. You know, you can go back to the shop using the same plastic bag and put your products in there and carry them home. But you can also use them for bin liners. It does not just shopping, it doesn't mean just shopping, so multiple uses. The paper bag, you can only really get one use out of it, especially if it gets wet or damp. You know, the paper bag isn't very strong, it won't really last, so you only really get one use. And then the last one in the LCA is product disposal. So plastic bags are non-biodegradable, and what that means is that the plastic bag will not break down, so it will take up space in landfill, which, you know, is not aesthetically pleasing. It will pollute the land, it could damage the environment, damage habitats, whereas paper bags are biodegradable, so they do break down, they're non-toxic, and they can be recycled. So there are pros and cons on both ends. You just need to make sure you know the differences, and if the question asked you to make a judgment and say which one do you think is better in terms of the LCA, then you've got to have reasons to back it up. So make sure you take some from here. So recycling materials is really important because you don't want to waste lots of materials. We don't want lots of materials ending up in landfill sites. You know, because the processes are expensive of creating products. So it's a good thing to recycle them because we are running out of fossil fuels, especially. Okay, so copper-rich ores are in short supply. So an ore is basically a rock which contains enough metal to make it worth extracting. And in this case, we're talking about a rock that contains copper. So one way to improve sustainability is by extracting copper from low grade ores. Low grade ores, and there's two ways of doing this. The first one is called bioleaching, and this is where bacteria are used. So bacteria are used to convert the copper compounds in the ore into soluble copper compounds, and soluble means it can dissolve in solution, separating out the copper from the ore in this process. So dissolving it in solution basically extracts that copper from the ore. The leachate is basically the solution produced by the process, and it contains copper ions. So copper ions are made in this process, and then you can use electrolysis in order to gain that copper. Now copper, I think, is it's 2+ or 3+, but it's a positive ion, so it's a cation, and the cations go to the negative electrode and gain electrons in order to form the pure copper metal. So that's one way, that's bioleaching. The second way is called phytomining. So make sure I spell it right, phytomining, and this involves growing plants in soil that contains copper. So growing plants in copper rich soil, and then what happens is the copper the plants get rid of the copper as it gradually builds up in leaves. So copper builds up in leaves as the plant is trying to get rid of it, and then the plants can be harvested. Plants harvested, dried, and burnt. Oh gosh, I've got it on the table. Burnt in a furnace. The ash, after you've burnt the leaves, contains soluble copper compounds, and then the copper can then be extracted by electrolysis again. So I'll just write that for you. The ash contains soluble copper compounds, and then we use electrolysis again in order to gain that pure copper. So that's two ways of gaining copper, but both of them end up in electrolysis. And if you're not sure on what electrolysis is and how it works, then watch my previous video explaining all of that. But bioleaching and phytomining are the two that you need to be aware of in order to extract copper.